Okay, this question I think was on page 118 of the textbook. It's from exercise 20. I was asked about question 1 and then question 4. So for both of these, for each function, draw the absolute value of the function and then the function with the absolute value of x. Okay, so let's just think of what this is. First and foremost, I think one of the best ways of doing this is actually we have a rule, and the rule is so f of x, if that's my original function, then the absolute value of that function. So there'll be no change when y is greater than or equal to 0. When y is less than 0, we reflect across x. Okay, I'm going to show you that in a second, but that's the rule that we're going to use, okay, when we have the absolute value like that. Now, when we have f, the absolute value of x, again, the rule is going to change a little bit as well. And there we go. That is just wonderful. See how technology is just our best friend? Right. Let me see if I can switch that back to blue. I'm good now. All right. And then when we're taking the absolute value of the x, what's going to happen is there's no change when x is greater than or equal to 0. When x is less than 0, we reflect across y. Now, that's going to be the interesting bit, but let's just look at these each first for this first function. So the first function we're looking at is y equals, I'm just going to rewrite this as negative 5x plus 2, really doesn't matter. Negative 5x plus 2, when I put in 0, it will be at 2. When I put in negative 1, it would be at 7. If I put in negative 2, it would be at 12. Similarly, if I put in 1, it would be negative 3. And then if I put in negative 2, excuse me, if I put in 2, I would be at negative 8, which is right there. So this function, and this is going to be a challenge here. Let me see if I can't do it with a line. This function, that didn't work at all. This function, why aren't we cooperating? It'd be really nice if we would. Sweet. Right, I'm back. Got it. Oh, gotta love technical difficulties. All right, I'm just going to go with this. We're going to make this work. I'm going to put a line in that starts right there, and I'm going to pull it straight down to look just like that. That's my y, that's just my f of x, okay? Now, if I wanted to do the same exact thing following my rules for the absolute value, if y is greater than 0, there's no change. So from the start of that, I get back to that picture. My next value, go a little bit thicker, I would end up going y is positive, still positive. Right here is where y is no longer positive. As soon as it hits the x-axis. Now what's going to happen is all of these points that we found before are going to flip up to the positive. So where this one is going to be, where it's at -3 to start with, it's now going to be at, or sorry, it's at -3. Now it's going to be at +3. I missed that one completely. There we go. +3 right there. And then 2 is at -8. It's now going to be at +8. And then again, if I drew that in using I would end up with something like that. Apologize that it's a bit of a mess. Now, for the other one, what's going to happen is as soon as this thing, so now my other rule is when I am having so much fun here. Look at that. All right, no change when x is positive, but when x is negative, this reflects across y. If I reflect across y, what's going to happen is it's going to come straight up. When it hits here and it reflects, it's going to reflect back up this way. So instead of being there, that would switch. Let me get this one. So it would go here, and then it would go here, and this function would look, it would still be all of these, and then it would reflect like that.